Hi, everyone. This is Ray Phillips of Precision Driving Analytics. And I just want to share with you some forensic data analysis. When I was at Road America this past weekend with my Ferrari Challenge customer, one of our drivers had an incident at Road America. And unfortunately, it was in the kink. But fortunately, he did a good job of minimizing the damage. So he was able to continue racing, and the team was able to get the car fixed. But if you watch the video, it looks like he turned in late, and that's kind of what the determination was initially. But it didn't seem 100% accurate to me. There was something there that I felt like I needed to dig into a little bit more, and that's where I used the data and along with the video to kind of determine that he didn't really turn in late. It certainly looks like that, but if you start slowing everything down, he actually turned earlier than the previous lap, which was a good lap. So anyway, I'm just gonna kind of share with you, my analysis and how I came to the conclusion that it probably wasn't his fault. So here's the video. Okay, so I'm going to show this video again with a little bit of narration on my part. All right, so he's going through turn 8, and he's coming to the carousel, and as you can see, he's going to pass this car offline. So there could be stuff offline there, but the car does get back to the curbing on the inside. And now he's going to start his turn in at the access road, but the car just doesn't turn. All right, so the question is why didn't the car turn? Was it something the driver did, or was it something on the track, or did something break on the car? We're not going to get the answer 100%, but I at least want to try to eliminate that it was a driver error. So that's kind of where I'm going to dig into the data. Now these cars have VBOX HD2 track kits in them, and so that's where the video is coming from. And the good thing about that is that they also have data coming in, and you can analyze that data with circuit tools. So I'm going to share my screen and look at the circuit tools with you. All right, so here's the previous lap in blue, which was a 212.69, and that's a decent lap. And then the crash lap is the second one, and that's in red. And I got the two videos side by side, and below I have speed, lateral G's, steering at the wheels, throttle, and brake. So first, I kind of want to determine, when he started to turn the car, and that's basically right at this point. So if I'm looking at steering here, I can see that the red line starts to separate from the blue line. And if I even look at the video, I can see that he's got slightly more steering input on the incident lap than he does in the previous lap. And the car seems to be positioned about the same place. I can look at speed. He's going actually a tad slower at this point, only what, 8 100ths slower miles an hour. So, not really a big difference. And he's just gotten off the throttle. So he's doing his lift before his turn in. So he's transferring weight to the front tires by doing that. On his previous lap, he's actually a little further ahead Okay. And he still hasn't started turning the wheel. Now, from the video, you can hear that he does get his tires up on, this yellow and red curbing on the incident lap. But, and I do believe that's a factor, because once you get up there, the car is not going to want to turn like it should. But if he was turning before that point, and he's not really any closer to the edge of the track or anything, why did the car not stay off of that? So if he had, some steering angle, the car is still going straight here. So that's why he ended up on there. And he's probably looking over here. So he may not realize that the car isn't reacting to, his little bit of steering input. And granted, this isn't a lot at this point, but still there should be, some load on that left front tire to say that, I've got to change the direction a little bit, so as he puts more steering into it, you can see that, now he's definitely up on that yellow and red curbing, and he's got, let's see, almost 3 degrees of steering at the tire, which is like 33 degrees at the steering wheel. So that's a decent amount of steering input at that point. So the car does start to turn a little bit, but he just hasn't gotten away from that edge. And the problem is that the track is just going to get worse and worse if you're not online. So he's slightly offline at this point. And then this doesn't turn and makes it to the wall, unfortunately. And even tries to put some brake pressure in it to get more weight transferred to the front of the car and basically get the thing slowed down to prevent it from going into the wall. And you can see at this point he's got quite a bit of understeer, 5.2 degrees compared to 2.9. So the car just isn't going to get there. So the other thing about these cars is that they have a factory installed Magneti Marelli data system in them, and so I use WinTax software to analyze that. So I'm going to go back over to the WinTax and take a look at what I'm seeing there. So I'll share that screen with you. All right, so here's the WinTax data. Again, I get a little bit more information from WinTax than I do, the VBOX or any other data system that I could put in there, to be honest. So pretty much the same type of stuff. I've got the speed of the left front tire, since I can look at wheel speeds. That's there. And I want to make sure that it's not locking up or, something else is causing, the car not to be able to turn. I've got the steering angle here. I've got lateral G's here. And I've got understeer and oversteer here. I've got throttle and I've got brake. So I've also changed the scale so that, you can see some of the stuff a little bit easier, see slopes and those types of things. So I can see that, lateral G's is basically, it hasn't really changed, oh, sorry, I'm looking down here. Lateral G's really hasn't changed even after he starts putting some steering input. So that's the steering up here. So you can see, this is a point where it really starts to separate. And again, that's at the same point where, he gets out of the gas, and that's at the start of that access road is where that started to happen. So lateral G's don't change until here, when he's got 21 degrees of steering angle, which is about 2 degrees or so at the front tires. So, and check out the understeer oversteer. that's right at the point where it starts to build. Okay. So more steering input, no real lateral G build up, and the understeer starts to develop. So you can see that, this was his understeer trace on the previous lap, and this is the one on the incident lap. So that gets up to 5.3 degrees, which is what we pretty much saw in the VBOX video. And at this point, he's on the brakes, pretty hard. He's giving it 90 bar brake pressure. And he's at this point, he's probably in the grass or just about in the grass. And at this point is when he hits the wall. There's 4.1 G's there. So based on this information, I don't think the driver was at fault for getting offline and having the incident. Sometimes these things just happen. I do think that it shows the importance of having video and data, though, because the video was able to show us like the car's position in relation to like access road and the car getting up on that yellow and red curving, and the data was able to show us, like the understeer, oversteer, and those types of things, and we're steering exactly started to happen. So we were able to go just a little bit deeper with the data, and hopefully you enjoyed that analysis. If you do need data and video equipment, please reach out or check out my website at precisiondrivinganalytics.com. My email is rphillips@drivinganalytics.com. So if you have any questions about what I just presented, or any questions about different type of equipment, then just please let me know. Hopefully you have a good day. Take care. Bye.